Hello everyone. Today we will be discussing the quick solutions of All India AIATS Test Series Test 8A Paper 1 Mathematics, which was held on 9th May 2019. So let us start with the question number 37, which says that if the function f satisfies equation is given for all x belonging to R, then we have to answer the following questions. So in the question it have been given to us that f of x minus 1 is multiplied with x square plus x plus 1 whole square minus fx plus 1 multiplied with, here it can be seen that x raised to the power 4 plus x square plus 1. We can write it equal to x square plus x plus 1 multiplied with x square minus x plus 1. We can use this property here. So writing it down here, we will get x square plus x plus 1 multiplied with x square minus x plus 1 equal to 0. Right? So here it can be seen that x square plus x plus 1 is equal to 0, or fx minus 1 multiplied with x square plus x plus 1 is equal to f of x plus 1 multiplied with x square minus x plus 1. I am not writing the other case, that is x square plus x plus 1 equal to 0, because that will not give me any real solution. So this is the only equation that we will get from here. So I can say that fx plus 1 divided by fx minus 1 is equal to x square plus x plus 1 divided by x square minus x plus 1. So here by componendo dividendo we can say that the value of fx is equal to x square plus 1 divided by x. So this is the function fx that we have obtained. Now let's see option number A. It says that the solution of the equation f of gif of x equal to 2 is. So f of gif of x, that will be equal to greatest integer of x square plus 1 divided by greatest integer of x equal to 2. That means that greatest integer of x plus 1 by greatest integer of x is equal to 2. So this is possible only when greatest integer of x is equal to 1, which means that x will belong from closed 1 to open 2. So option A is correct. We can write it here directly, x plus 1 by x. Now option number B says that number of solutions of f of fractional part of x, that is fractional part of x plus 1 by fractional part of x is equal to 2, which means that fractional part of x should be equal to 1, but that is never possible, which means that this option is incorrect. Now C option says that minimum value of f of x square, that will be x square plus 1 by x square plus 3 by x square is, so this is equal to x square plus 4 by x square. Now here we can apply AMGM inequality, which means that this will be greater than equal to 4. So we can say that the minimum value of f of x square plus 3 by x square is 4. So this option is also correct. Option number D says that modulus of fx is less than 2, which is not correct, because fx is either greater than equal to 2 or less than equal to minus 2, which means that its modulus is always greater than equal to 2. So answer of this question will be option number A and C. Next is question number 38, which says that let S be the set of all possible 2 cross 2 matrices A of integer entries such that A multiplied with A transpose is equal to 2i, where I is equal to 1 0 0 1. Then we have to find the number of such matrices. Right. So let us assume here matrix A equal to A, B, C, D. So it have been given that A multiplied with A transpose, this is equal to 2i. So this will be equal to A square plus B square, AC plus BD, AC plus BD, C square plus D square. So this is the matrix and this is given to be equal to 2i, that is 2 0 0 2. right? So all the respective elements will be equal, that is a square plus b square will be equal to 2, c square plus d square will be equal to 2, and ac plus bd will be equal to 0. So this is the condition that we get from here. Now to find number of such matrices, we have to take different values of a, b, c, d and check by hit and trial how many matrices do we get. We have different possible values here: 1, 1, minus 1, 1, 1, 1, 1, minus 1, which will be satisfying these above conditions. Next we have 1, 1, minus 1, 1, 1, minus 1, minus 1, minus 1. Further we will have minus 1, 1, 1, 1, minus 1, minus 1, 1, minus 1. These are the only possible entries. So we can say that number of such matrices in S will be 8. So option number A is correct and option number B is incorrect. Next we have to find the number of such matrices in S such that determinant of A minus I is equal to minus 1 or not equal to 1 is. So let's firstly find the determinant of A minus I. So that is determinant of A minus 1, B, C, D minus 1. So its determinant will be equal to A minus 1 multiplied with D minus 1 minus BC. So let's find its value also here. That is A minus 1 into D minus 1 minus BC. So its value here will be 1 minus 1, 5 minus 1, 1 minus 1, minus 1, 5. So these are the values. So we can say that number of such matrices for which its determinant is not equal to 1 is 1, 2, 3, 4, 5, 6. So we can say that option number C is correct. Now for determinant of A minus I to be equal to minus 1, we have 1, 2, 3 and 4 such matrices, which means that option number D is also correct. So answer of this question is A, C and D. Next is question number 39, which says that if f double dash x is less than 0 for all x and gx is equal to f of x square plus f of 4 minus x square, then gx is increasing in the interval. Now f double dash x less than 0 means that f dash x is an decreasing function. Now it has been given that gx is equal to f of x square plus f of 4 minus x square. So we have to find where gx is increasing, which means that we should find g dash x and put it greater than 0. So g dash x will be equal to 2x, taking common, f dash x square minus f dash 4 minus x square. Now this should be greater than 0. So we have two cases here. Case 1, that is x is greater than 0. Now if x is greater than 0, then f dash x square should also be greater than f dash 4 minus x square. Now as f dash x is a decreasing function, which means that x square should be less than 4 minus x square, which means that 2x square is less than 4, that is x square less than 2. Now as x is greater than 0, so we can say that x will belong from 0 to root 2. Now similarly, let's take case number 2, where we will take x less than 0. So we can say that f dash x square is less than f dash 4 minus x square, which means that x square will be greater than 2. Now for x less than 0, we can say that x will belong from minus infinity to minus root 2. So these two are the answers that we get from here. So from the given options, it can be seen that option number C and D are the correct answers. Next is question number 40, a very short and sweet question. So let's solve it. Which of the following is correct? Right. So let's go option by option. Option number A says that limit of x tending to 0. Here we can write it as multiplying 2 in the numerator and denominator. We will get 6 times sine 2x divided by 2x. Now we know that limit t tending to 0 sine t upon t GIF is slightly less than 1, so it is equal to 0. So in this case it have been multiplied by 6, so it will be slightly less than 6, which means that it will be equal to 5. So option number A is correct. So option number B is incorrect. Now option number C, we can find limit x tending to 0 sine x divided by x fractional part. So that will be equal to limit x tending to 0 sine x by x minus limit x tending to 0 sine x upon x GIF. Now we know that this will be 0. So this is equal to limit x tending to 0 sine x upon x, that is 1. So its value will be equal to 1. So option number D is also correct. So answer is A and D. Next is question number 41, which says that at which of the following points the function fx equal to x square minus x when x is a rational number and it is 0 when x is not a rational number is continuous. Very simple, it will be continuous only when both the terms are equal, that is x square minus x is equal to 0, which means that x equal to 0 or x equal to 1. So from the given options, option number A and B are the answers. Other than these points, there will be no such point where the function is continuous. Next is question number 42, which says that if x square plus 2y square is equal to 4, then we have to answer the following questions. So an ellipse have been given, that is x square upon 4 plus y square upon 2 equal to 1. So a point on it can be taken as 2 cos theta and root 2 sin theta. So we have to find the maximum value of x plus 2y. So that will be equal to 2 cos theta plus 2 root 2 sin theta. We know the range of this function, its maximum value will be under root of 2 square plus 2 root 2 whole square, that is 8. So this is equal to under root of 12, that is equal to 2 root 3. So answer will be option number B and option number A is incorrect. Now we have to find the maximum distance between the points x, y and 1, 0. So firstly let's find the distance. That will be equal to under root 2 cos theta minus 1 whole square plus root 2 sin theta minus 0 whole square, that is 2 times sin square theta. Now it will be equal to under root 4 cos square theta. Now 2 cos square theta plus 2 sin square theta can be written as 2. So we are left with 2 cos square theta minus 4 cos theta plus 2 plus 1, that is plus 3. So this is equal to under root of, taking 2 common, we will write cos square theta minus 2 cos theta plus 3 by 2. That is equal to under root of 2 times cos theta minus 1 whole square plus 1. So we can say that maximum distance will be equal to when cos theta is equal to minus 1. So it will be minus 1 whole square, that is 4 into 2, that is 8 plus 1, that is 9 root, that is 3. And its minimum distance will be when cos theta is equal to 1. So minimum distance will be 1. So from given options, it can be seen that option number D is the correct answer. So answer of this question will be option number B and D.